Okay, delta TF equals to I, which is Van Hoff factor, M, which is molality, and Kf, which is a constant. We are trying to determine this constant here, which is a known value for water. We know it's going to be about 1.86, but let's say we have a data set for trial 1. So this will be different than the one you have on your dry lab. But trial 1, let's say freezing point of pure water is 0.9 Celsius, and the mass of sodium chloride we use will be 3.331 grams. Freezing point of salt water is going to be negative 2.2 Celsius. Mass of the saltwater solution in this case is, if it was in grams, is 115.370 grams. Or if we have to convert it to kilograms, we divide it by 1,000, which is then equals to 0.115370 kilograms. So the first thing we want to do is we need to get moles of NaCl that's used. So to get moles of NaCl, we need the molar mass of NaCl, which is 58.44 grams per mole. So we take grams of the sodium chloride, and then we use the fact that 1 mole of NaCl weighs 58.44 grams of NaCl. We will get moles this way. If we put this in your calculator, we'll get 0.05700 moles. So once you get moles of NaCl, we will be using this moles here later for molality. Okay, the next thing we want to do is go ahead and find the mass of water. Okay, so that's the first step. The second step is to look for the mass of water. Where mass of water is you take the saltwater solution, the grams minus the salt grams. And then obviously they want it in kilograms, so we'll have to convert both the kilogram values. Okay, so easy way to do this is simply take the grams, 115.370 grams. This is the salt water, and then we'll take it and subtract the salt out, which is 3.331 grams. So this here will give me just the mass of the water, which is 112.039 grams. Okay, convert this to kilogram, which you divide it by 1,000, we will get 0.112039 kilograms. Okay, now the next thing we want to do is go ahead and take this kilogram and take this moles here. We can get molality of the solution, because molality, the unit, is moles of the solute divided by the kilograms of the solvent, which is water. Okay, so molality in this case would be 0.05700 moles of NaCl divided by kilograms of water, which is this value over here, 0.112039 kilograms, and we get a molality value. In this case, it's 0.5088 moles per kilogram, and which is the same as molality. Okay, now once we have molality, we will go back to the formula on the top here. We'll use this. We'll put the molality in here. We know that I is 2 because it's NaCl. Sodium chloride has 2 ions when it splits in water, so the I is going to be 2. So we also know the delta TF. Delta TF is the difference between the original freezing point difference from original and it fell down to negative 2.2. What's the difference there? We always use absolute value for this. So what we do is take basically is going from 0.9 Celsius, right? And then it's going to 2.2. So the difference between that is, well, I guess we should do, I would do the absolute value. Let me rewrite this. Absolute value of negative 2.2 Celsius minus 0.9 Celsius. Okay, so that would give me 3.1 Celsius, because 2.2 and 0.9 makes it negative 3.1, so I'll get positive 3.1. So then that was my delta TF. This is my delta TF here. So we'll take 3.1 Celsius as my delta TF equals to I, which is 2, and then M is this value here. Sorry, couldn't see. So again, delta TF is 3.1 right here. 2 is my I, M is my molality, 0.5088 moles per kilogram. And then I have KF. Okay, so in this case here, we can solve for KF. KF would be literally take this value divided by these two. So KF becomes 3.1 divided by 2 times 0.508, which then we get 3.046, but since we're only keeping 2 sig figs here, because this is an unlimited sig fig, so we will keep 2. So it will be 3.0 Celsius over molality. Obviously, this answer is really off, because the answer you should get is something close to 1.86. But we are getting 3 here. So to do the percent error, all you do is you take the formula. We'll take your actual value. Okay, so percent error is the absolute value of your actual, so 3.0 minus 1.86 divided by the actual. If the book says it's 1.853, go ahead and use that value as well. But either way, we take less than 10 per 100. In this case, it's a really big error, 61.90%. But in your case, it will probably be smaller. Hopefully this helps. Good luck.